Hello, I'm Michelle Crummell, and in this video I'm going to show you how to type commonly used mathematical notation in LaTeX. I'm working with the software program called TexMaker, but you can use any text editor that you like. If you watched my previous video creating a LaTeX document, I showed you how you can use Overleaf so that you don't have to download and install any software. Overleaf runs right in your web browser. So there is a link in the description below that you can click on if you want to create an Overleaf account and work purely online. If you want your screen to match mine exactly, you're going to want to download TexMaker. Make sure that you do have MikTeX or MacTeX installed before you install TexMaker. So I am in TexMaker right now, and I'm going to create a new file. So just click on that icon here, and it looks like I have a new file ready to go. It looks like it might be called Untitled 1, but actually we haven't saved this. We haven't really created it yet. So before we start typing any code, this is very important. We need to save this file and name it. Otherwise, you could type all kinds of code in here, and when you go to compile, you're just going to get an error, and it's not going to be able to do anything. We have to save this file and name it first before we're going to be able to compile it. So let's do that. File, we'll save as, and you can save it anywhere you like on your computer. I'm just going to call this one tutorial 2. And I mentioned in my last video, you don't want spaces in your file names. Your text files should not have any spaces in the file name. So use an underscore or a hyphen, or simply just, run all of the words together. And that will automatically assign an extension of .tex to that file. So here's my tutorial 02 tex file, and now I can start typing my code. So we always start with \document class, and TexMaker is making this suggestion for me, so I can hit enter as a shortcut here and have it fill in some of that for me. Now the square brackets are where we would place optional arguments here. It's unnecessary. If I didn't want that, I could delete that and just have the curly brackets. We do need the curly brackets here. The class that we are using today is article. So that's fine, I can do that. If I do want to include some optional arguments, one of the more common ones would be to declare the font size. So your choices are 10 point, 11 point, or 12 point. I usually like to go with 11 point. And then we're always going to have \begin document and \end document, that pair of commands there. So I'm not going to compile yet. I don't actually have any content. We have to start typing something first. We're working on mathematical notation today, so I'm just going to go through lots of different categories and then show you how to type various expressions that you might need. So let's start with superscripts. So I'm just going to type the word superscripts, and now that I have something here, when I build, we should be able to see that. And I'm just going to set this to, oops, not that. We just set the width here so that we're seeing the whole page. That looks about good right there. Okay, so superscripts, and we want to actually type something with a superscript in it. So that was just in text mode, and I'm going to type 2x to the power 3, so 2x cubed. 2x, for the exponent, we use that caret symbol from the keyboard. So there's 2x cubed. However, if I compile this right now, I'm going to get an error because this caret symbol needs to be in math mode, not in text mode. So to put this in math mode, remember we wrap it in $signs. And now I can build. So I'm building by hitting this arrow up here, which is quick building for me. So it's doing two things. It's compiling the code and producing the PDF that we see over here on the right. But I usually prefer to use my keyboard shortcut, which is just F1. So if you don't see me come up here and press this button in the video, then it's because I just hit F1 on my keyboard. If I hit F1, then it will compile. So I can tell that the 2x cubed is in math mode because it turned green. That's one of the nice features about TexMaker that I like. It does color code different parts of the code, so it's easy to keep track of what you're doing. And if we look at our results, we've got, I mean, it's okay, superscripts 2x cubed, but I would like to separate the 2x cubed from the text and put it on its own line. So we're going to do that by using displayed math mode. I'm going to use $2 symbols at the beginning and the end of that, and it puts the math mode on its own line centered on the line, like so. So next we're going to look at 2x to the power 34. Again, I'll use this displayed math mode, 2x to the power 34. So think about what that's going to look like. The fact that I used double dollar signs means it's going to be placed on a separate line and it'll be centered on that line. So I don't have to worry about putting in any kind of manual line break like we practiced in the first tutorial. The double dollar signs will automatically start a new line for me. So that's fine. But if I want 2x to the power 34, what I'm expecting to see is x in the base and 34 in the exponent. And if we build this, and let me zoom in a little bit more so it's easier for you to see. If we build this, you can see that the 4 didn't go up into the exponent. So by default, when you use this caret symbol, only the single digit that comes next is going to be placed in the exponent. If you want more than that in the exponent, then you have to use curly brackets. And you can use the curly brackets even if you only have a single digit, but I normally don't bother. If it's just a single digit, I don't bother putting the curly brackets. But now when we compile, we can see that the 34 has moved up into the exponent, which is what I had intended. So another example, let's do 2 times x to the power 3x plus 4. 2 times x to the power 3x plus 4. So if I want 3x plus 4 all to be in the exponent, then I need to put curly brackets around that. And that looks like I expected it to look. And then let's do 2x to the power 3x to the 4th plus 5. So we're going to have an exponent inside of an exponent. So 2x to the power, curly brackets. Now generally when I'm doing this, I find it quicker and easier if when I type the first curly bracket, I go ahead and type the end one as well. So that way I don't forget it at the end, especially if I'm going to be using multiple curly brackets. Just makes it less likely that I'm going to forget to close one of my opening brackets. And then sometimes I'll even just go ahead and do the same thing with my dollar signs. And then I can just back up and enter what I need to inside of the brackets. So we're going to put 3x to the 4th plus 5. 3x to the power 4 plus 5. So this exponent here, I didn't bother to use the curly brackets. I could have wrapped the 4 in curly brackets, but since it's just one single digit in the exponent, it's unnecessary. Okay, so now we have 3x to the power 4 plus 5 all in the exponent here. And now let's move on to subscripts. Subscripts work in a similar way. So let's start with x sub 1. X sub 1. To get the subscript, you use the underscore. Is that what it's called? Underscore, and then whatever you want in your subscript. And again, it will only put the next single digit into the subscript unless you use curly brackets. So here we've got x sub 1, and if I want x sub 12, for example, x sub 12, this is not going to work. It's still going to just do x sub 1 and then put a 2 right next to that. So that's not what we want. Here we want 12 to be in the subscript, so we put curly brackets around the 12. And now we've got 12 in our subscript. You can have subscripts inside of subscripts as well. So let's just do x sub 1 sub 2. And I think this might cause an error if we just type it like this. Yes, it did cause an error. So we have to use curly brackets here so that the compiler knows what it is we're trying to do, because it's different if you want x sub and then 1 sub 2 versus x sub 1 sub 2. So you have to decide how you're going to put your curly brackets, where you're going to put your curly brackets. Generally, I would say x sub, and then everything you want in the subscript should go in curly brackets like this. Now look inside your curly brackets. Do we need more brackets? Well, since there's just a single digit after the 2 right here is just a single digit after this subscript, we should be okay with this. Let's see how that looks. So that's x sub 1 sub 2. And we could even go further with that if we wanted to do x sub 1 sub 2 sub 3, like so, but we're going to have to figure out our brackets. So x sub, and then use curly brackets around your entire subscript. Now within that curly brackets, we need more brackets because we've got 2 subscripts in there, so we want to be clear. 1 sub, and then we'll put curly brackets around the 2 sub 3. So I'm like nesting my subscripts here. Let's see how that looks. So 1 sub 2 sub 3. And you could continue, to do this as many times as you need to. So let's do one more example. Let's say we have a sequence, and I'm not going to use the curly bracket notation, and let me just list some values. So we might have a sub 0, comma, a sub 1, comma, a sub 2, comma, and then I want dot, dot, dot. I'm not going to type the dot, dot, dot. There is a LaTeX command for that. Backslash L dots is going to do 3 dots. The L is for lower. They're going to be aligned at the bottom, like lower aligned, versus C dots would be aligned in the center. But L dots will work for me fine right here. And then we'll say a sub 100. Now with 100, again, I'm not going to type it like this, or it's only going to be a sub 1 and then 2 zeros next to it. That's not what we want. We want 100 to be in the subscript. So we need curly brackets there. There we go. So a sub 0, a sub 1, a sub 2, dot, 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 a sub 100. Next, let's look at some Greek letters. So we often use Greek letters in math notation, and one of the most popular Greek letters that we use is the Greek letter pi. If you want to type pi, it's just backslash pi. Now that is the lowercase pi. If I wanted the capital Greek letter pi, backslash capital Pi, like so. And that's the capital pi. If we want other Greek letters, we can just type the name. If you use a capital letter, it's going to give you a capital Greek letter. If you use lowercase, it's going to give you the lowercase Greek letter. For example, we can do backslash alpha. And that's going to give us the lowercase Greek letter alpha. So you get the idea there. And we might do something like A equals pi r squared, right? Area of a circle. So backslash pi. Now it's important here that I enter a space and then do my r squared. Otherwise, if I don't have the space there, let me take out the space and show you that because it's all running together, the compiler sees the command as backslash PIR. Backslash PIR is not a valid LaTeX command, so it's going to get confused and we're going to get an error. Pretty sure we're going to get an error. Let's try. Yep, we're going to get an error. And you can kind of see it's giving me a hint here of what the error is. It doesn't like that PIR. So you have to put a space between your command and the next thing. And now it should be fine. There we go. Area equals pi r squared right here. Okay, so those are Greek letters. You can do many other Greek letters. I'm just showing you an example of a few. Let's talk about some trig functions. If we want to enter, for example, y equals sine of x, y equals, you're going to use a, first let me do it the wrong way, because my beginner students often will just type this and they might not even think there's anything wrong with the way that looks, right? I mean, you can read it. It says y equals sine x, but it is not displaying the way we would like our mathematical notation displayed. The compiler, because you're in math mode here, thinks that the s is a variable, the I is a variable, the n is a variable, and the x is a variable. And so it's typesetting them all the same way. You can see it looks very uniform the way these letters have been typeset. They're all italicized and spaced kind of the same way, and they're all running together. That's not how we want the sign of x to look. So we put a backslash in front of our trig functions, sine, cosine, tangent, secant, cosecant, cotangent. And now when I compile, you can see the difference. The sin is not italicized, and there's a little bit of a space between the n and the x. Okay, so this is how it's supposed to look. And we can do that for our other trig functions, like I said. Y equals cosine x. Tangent x is tan, backslash tan. If we want to do the reciprocal trig functions, y equals, let's just do cosecant, is CSC. Secant would be SEC, cotangent would be COT. And instead of x, let's just do theta. So theta is one of our Greek letters. We're going to do backslash and then type out theta. I want a lowercase theta here. So I've got y equals cosecant theta. And you can play around with it and see, what happens if you did a capital theta. Well, we would get the Greek capital theta, but that's not what we normally use for angles. We use the lowercase. There we go. So you don't want to forget when you're doing your trig functions, sine, cosine, tangent, secant, cosecant, cotangent, to put the backslash in front and the space between the trig command and then the argument or the angle. We can do inverse trig functions as well. So let's do sine inverse of -1. Y equals sine inverse, so backslash sine. And then for inverse, that we're going to use the notation where it puts a -1 as a subscript. So remember how we did subscripts. It's the caret. I want -1 in the subscript. So I can't just do this. That's not going to work. That's only going to put the negative symbol in the exponent. The 1 will not be in the exponent if I do that. So I have to use curly brackets, -1, like so. And then x or theta or whatever we happen to be using. Oh, I did say sine inverse of -1, didn't I? Although that's a little confusing because we would have -1 in two different places. But if I wanted the sine inverse of 1/2, for example, we haven't done fractions yet. We're about to do fractions. Let's keep it simple. Sine inverse of 1. There we go. Could do that. Or theta or x or whatever we need there. Okay, so that's sine inverse. Now we could also use the arc sine notation. Instead of using that -1 superscript, we can just do y equals arc sine, and it again is backslash, and then you type arc sine, ARC-SIN, and then your angle. Okay, so by putting the backslash in front of the arc sine, it's indicating to the compiler, hey, these are not variables, don't typeset them like variables. So it looks like it's supposed to look here. Okay, let's do log functions next. And we will start with just a common log, y equals log x. Now again, think about what's going to happen if I compile this right now. I'm in math mode. It sees the y, the l, the o, the g, the x, thinks those are all variables, so it's going to look funny. I mean, you can understand what it's supposed to be, right? But I do see beginning students doing this a lot in their papers and forgetting to put the backslash in front of the log. Use the backslash, and then you need a space between the g and whatever comes next. And then it will typeset this correctly. So only the variables x and y are italicized and the rest of the equation is not. So there's our common log, y equals log of x. Let's change the base in our log. So if we want log, backslash log, oh, that's supposed to be equal, y equals backslash log. If we want base 5, for example, we need a subscript. So remember how we did subscripts. It's the underscore 5. And then I'm going to type a space. It's not strictly necessary because if I don't use curly brackets, it will only subscript the next digit. But just to be clear, I like to always put a space there like that. So this log, oh, what did I do wrong? Oh, I'm missing a dollar sign. Double dollar signs. Okay, log base 5 of x. And then let's do a natural log. Y equals \ln space x. That's going to give us a natural log. Next, let's talk about square roots, and not necessarily square roots. Let's just say roots in general, because we can see how to do cube roots or fifth roots or seventh roots. So we'll just say roots in general. We'll start simple. Square root of 2. So to do a square root, we're going to hit \SQR, and TexMaker is making 2 suggestions for me here. So we can see it's \SQRT, and then we have an option where there's square brackets, curly brackets, or we have an option where it's just curly brackets. If you're just doing the square root of 2, you don't want the square brackets, you just want the curly brackets. So SQRT, curly bracket to curly bracket, like so. And that's going to give us the square root of 2. The other option is for when you want roots that are not square roots. So let's do the cube root of 2. You're still going to type \SQRT. So it's like you're starting the square root command even if it's not a square root, but then you're choosing the one that has the square brackets followed by the curly brackets. So I can hit enter here to accept that and then start typing, or I could just keep typing it manually. So here, the square brackets are for the root. If I want a cube root, then I type a 3. The curly brackets are for what goes inside of that radical symbol. So we want the cube root of 2, it's going to look like so. Cube root of 2. Now this one down here is my page number. It's bugging me a little bit. So I'm going to go ahead and turn off the page numbers. And to do that, I'm going to scroll back up. And I am going to, after document class, I'm going to type \page style, curly brackets, empty. And I think that'll take care of that. So let me recompile. And then, yep, our page number is gone. So I'm turning that off just so that's not in our way. Okay, back to more roots. Let's do something more, a little slightly more complicated, like square root of x squared plus y squared. So \square root x squared plus y squared. Okay, looks good. And now let's get a little more complicated and put a square root inside of a square root. So the square root of 1 plus square root of x. So we'll start with the outside root, the square root, oops. Okay, the square root of. Now, once you start putting things inside of other things, it can get a little bit confusing. So what I will sometimes do is just insert some extra spaces, just so it's easy for me to tell what's inside of what, because it's got a little cushion around it. So this is my, like my outside square root, my big square root. And inside of this square root, I'm going to put 1 plus the square root of x. So 1 plus \, square root of x, like so. And compile. And we've got 1 plus, or the square root of 1 plus square root of x. All right, and then finally, let's look at fractions. So we'll start with something really simple. We'll just do the fraction 2/3. So the command is \frac for fractions. And you can see that TexMaker is prompting me. I can hit enter to accept that. And this is in general what it looks like when you want to make a fraction. Or if I'm typing it manually. If I'm typing it manually, I usually still do kind of a template thing. So I'll do curly brackets for the numerator and then curly brackets for the denominator. And then I'll just use my cursor and go back in. And that way I don't forget to close my brackets. So you have a pair of curly brackets for the numerator and then the next pair of curly brackets for the denominator. So in the numerator is 2, and in the denominator we want 3. So this should give me the fraction 2/3. Okay, that looks good. Now next I'm going to type this in a sentence. So let's just say about, and because I'm typing this in a sentence, I'm not going to use double dollar signs. I'm going to use single dollar signs because I want this to be inline math mode. So my fraction 2/3, and I did that more quickly using my keyboard because, let me do that one more time and explain. Backslash, okay, so here I just hit enter because TexMaker is going to populate that for me, and notice it automatically highlighted the numerator, so I type 2, and then I can hit tab on my keyboard and then type the 3. So it goes pretty quick once you get the hang of it like that, rather than just typing it manually. So about 2/3 of the glass is full. And there's that sentence. So the 2/3, it's smaller, obviously, in this sentence than the 2/3 up here. When you're in inline math mode, it's going to resize to fit your sentence, right? You don't want this huge 2/3. But sometimes, like if you're writing a homework problem, quiz, a worksheet, something like that, sometimes your fraction is too small in the sentence here, and you do want to make it larger. So easy way to do that is instead of \frac, use \dfrac. The D is going to put it in displayed math mode, dfrac. So now when I compile it, it's going to be, it didn't like that. Oh, I may need a package in order to use that. Okay, let me try this. Let me try this a different way, because I haven't talked about packages yet. But packages, we will be using packages soon. Another way to get into displayed math mode is to type \display style. Let's try that. There we go. So now it made the 2/3 bigger, same size as it made it up here. When you use double dollar signs, you're automatically in displayed math mode, and so everything is large like this. If you just do the \frac in inline math mode, it's going to be small. So this looks kind of silly. The 2/3 is really big compared to the rest of the sentence. I don't like that, so I'm going to, well, I'll leave it in here just for tutorial purposes. Let's maybe copy that one more time and take it out. Take out the display style, so you can see a comparison. Now, because I'm not using double dollar signs, it's not automatically creating a new line. So here's where we have to decide how we're going to break that line. Do we want to do a double backslash like that, which will break the line? You can see I'm sort of running into an issue here because the lines are not far enough apart. I can manually add some vertical spacing using square brackets, and then inside the square brackets tell it how much space I want. So 6, and then you can use any unit of measurement here. You can use centimeters. 6 centimeters would obviously be way too big. I usually use PT, point, like point size. So give me 6 points of space at the end of this sentence. And then when we compile, you see it inserted some vertical space there for me. Your other option, if you don't want to break the line that way, would be to leave an empty line in between, and that would also create a line break. We talked about this in the last tutorial though. Notice it looks odd because this new line right here is starting a new paragraph and it's indented, versus this line up here did not. This line up here is not indented, so that's why it looks a bit funny there. So I usually, and it just depends on what you need, but I usually do something like this when I want line breaks. And generally, if I want displayed fractions, display style fractions, and rather than typing out display style, I just do \dfrac. But I did get an error when I tried that a moment ago. Let's try it again. Not that I'm expecting anything different. 2/3. And I just have to figure out which package I need to use in order to get that to work properly. So I'm going to go back up to the top and really quickly just figure this out. Use package. And let's go with AMS Math. I'm gonna use a couple packages here because I don't want to do them one at a time and try and figure this out. AMS Math, AMS Sim, and AMS Fonts. Okay, one of those worked because now it did compile correctly. And oh, that was unnecessary because I had double dollar signs. Let me try that one more time because the double dollar signs automatically put it in displayed math mode, so it's kind of redundant that I used defrac inside of double dollar signs. It's not necessary to do that. Let's just try this again and verify that we are getting a large fraction here when we use defrac. Yep. And I need a line break there. Okay, so you can accomplish the same thing this way and this way. Let's try a more complicated fraction. So I'm going to do a line break here again. No, I'll go ahead and put it in double dollar signs, so this isn't technically necessary. Let's do this. Let's do a square root inside of our fraction. So let's do the square root of x plus 1 over the square root of x plus 2. So we'll start with fraction. Fraction, like so. In the numerator, we want the square root of x plus 1. So backslash square root, like so, x plus 1. That's my numerator. Then here is my denominator. So we're going to do square root x plus 2. And then close our dollar signs. And there we go. So I did use, TexMaker to my advantage there. I wasn't typing it all out manually. Let's try that one more time. If I were typing it out manually, backslash frac, your curly bracket, then slash square root. You have to open another curly bracket. So at this time, you have to kind of mentally keep track that you have two curly brackets open, and eventually you need to close the two curly brackets. So x plus 1, close it for the square root, close it for the numerator. Then we open curly brackets for the denominator, backslash square root, open curly bracket for the square root, x plus 2, close the square root, close the denominator, and then close math mode. And there we go. Now, sometimes we work with complex fractions where you have a fraction inside of a fraction. So let's try that. So outside fraction, and let's do 1 over, so just 1 in the numerator, that's it. And then in the denominator, let's do 1 plus 1 over x. So 1 plus, and now I need a fraction. So backslash frac, 1 over x, like so. 1 over 1 plus 1 over x. And you can, of course, have fractions inside of fractions inside of fractions. You just want to pay attention to your brackets, make sure that they're paired. And like I showed you a moment ago, sometimes it is helpful to space things out. So my denominator here had a bunch of stuff in it. You might find it helpful to kind of leave lots of space in the curly brackets for the denominator so that if you do get a compiling error, you can go back and see that's probably where it would have occurred because you've got complicated things inside of other things. So that can be helpful as well. That wraps up this tutorial on common math notation. I do have another tutorial on calculus notation, which will be much more involved. There's lots of notation that we use in calculus that we need to use LaTeX for because you can't type a lot of the calculus notation using your keyboard. But in the next tutorial, before we do that, the next tutorial, we're going to look at brackets, tables, and arrays. So brackets include things like parentheses and square brackets and curly brackets and absolute value symbols. We're going to see how to make those things expand in size, because if you just type parentheses, let me show you real quick, right here around this it's going to look really bad. Well, actually, it doesn't look too terrible, but the 1 over x here is longer vertically than the parentheses. So we're going to see how you can fix that, make your parentheses taller so that they do wrap around the content inside of the parentheses. And then we will look at tables. We'll do a simple table, we'll do a slightly more complex table, and then we'll look at some arrays. Thanks for joining today and hope to see you next time.